It's pretty wild when you think about it. You type a message, hit send, and bam, it just shows up on a screen halfway across the world. We do this all day, every day, and we never really give it a second thought. But what's actually going on in that little split second? What's the secret sauce behind that message? Well, today, we're going to pull back the curtain.
And I'll tell you right now, it's not magic. It's actually this incredibly well-structured process called data communication. By the end of this, you're going to have a complete map of that entire journey, from your fingertips all the way to its final destination.
All right, let's dive right in. The first thing you gotta understand is that every single piece of data you send, I'm talking emails, videos, texts, you name it, is made from the same 5 basic ingredients. It's like a universal recipe. So on the surface, the definition is pretty simple. It's just moving data between devices through some kind of medium. But oh man, the details are where it gets cool. That device? That could be the phone in your hand or a massive server farm for Netflix. And the transmission medium? That's the actual road the data takes, and it could be anything from a fiber optic cable buried under the ocean to the Wi-Fi signal bouncing around your house.
And here it is, our whole recipe laid out. First, you've got the sender, that's you and your phone. Then there's the receiver on the other end. The message is, well, the actual data you're sending. All of that stuff has to travel along a medium, which is the physical or wireless path. And then you have what might be the most important piece of the puzzle, the protocol. This is the rulebook that makes sure both devices are speaking the exact same language.
So just to lock it in your brain, message, sender, receiver, medium, and protocol. These 5 things are the absolute foundation for everything else we're going to talk about. Get these, and you're already halfway there.
Let's just hang on this idea of a protocol for a second, because it's really the unsung hero of this whole operation. Think of it like a diplomat for your data. If you didn't have these agreed-upon rules for how to format the message, when to talk and when to listen, all you'd have is digital noise, just a mess. The protocol is what turns all that chaos into a real conversation.
Okay, so let's zoom in on one of those 5 ingredients, the medium. Remember, this is the physical pathway, the actual road your data travels on. And just like in the real world, there are a few different kinds of roads you can take.
And really, the choice boils down to 2 main categories. On one side, you have guided media. This is the physical stuff you can actually see and touch. Think cables. On the other side, you've got unguided media, or wireless, where the data travels completely invisibly through the air.
So when we talk about guided media, we mean real, tangible paths. Like the humble old twisted pair wires that used to carry our phone calls, or the coaxial cables that bring cable TV into our homes. And then there's the crown jewel, fiber optics. These are the super fast cables that are pretty much the backbone of the entire modern internet, carrying our data as literal pulses of light. So cool.
And for unguided? Well, that's the invisible world of your Wi-Fi, your Bluetooth, your phone's cell connection. In this world, the data is just flying through the air as radio waves or microwaves, sometimes even bouncing off satellites way up in orbit. These are the invisible highways of information that connect us wherever we go.
So, we've picked a road, either a physical cable or a wireless signal. Great. Now, how do we actually send the traffic, the little bits of data, down that road? Are we going to send them all at once on a massive superhighway? Or do we send them one by one down a scenic country road?
It turns out every single data transmission, and I mean every single one, falls into one of 2 modes, parallel or serial. This is a huge fork in the road, and it completely changes how the data gets organized for its journey.
The best way to think about it is this. Parallel transmission is like a giant 8-lane superhighway. 8 cars, or 8 bits of data, can travel right next to each other all at the exact same time. It's crazy fast. Serial transmission, on the other hand, is just a single-lane road. The cars, or the bits, have to get in line and follow one after another.
So yeah, parallel is all about raw speed. You send a whole group of bits at once, moving a ton of data very, very quickly. This makes it perfect for short distances, where it's easy to manage all those wires, like when you connect your computer to a printer that's sitting right next to it.
Serial, though, sends just one single bit at a time. Now, it's definitely slower, but here's the kicker. It's way more reliable over long distances. With only one signal, there's much less chance of it getting scrambled. And that's exactly why it's the standard for almost all long-distance communication, from your home Ethernet all the way to the global internet itself.
Okay, so let's stick with that single-lane road, the serial mode. If you're sending bits one by one in a long line, how in the world does the receiver know where one chunk of data ends and the next one begins? Well, it's all about timing.
And if we look at our roadmap again, we can see that this single-lane serial road splits again into two main timing methods, asynchronous and synchronous. Let's break down what those mean.
Asynchronous basically means not in sync. With this method, each character or byte of data is wrapped in its own little package. It gets a start signal at the beginning and a stop signal at the end. This tells the receiver, hey, a character is starting now, and okay, it's over. It's really flexible, but all those extra start and stop bits create what we call overhead, which just means you're wasting time sending signals instead of actual data, and that slows the whole process down.
Now, synchronous transmission, this is a whole different ballgame. Here, both the sender and the receiver are perfectly synchronized to the exact same clock. The sender just unleashes this continuous stream of data, and the receiver knows precisely when to check the line for each new bit. It's like a perfectly choreographed dance. No need for extra start and stop signals. You just get a constant flow of pure data, which makes it way more efficient for sending huge files.
So you can see the difference pretty clearly here. Synchronous is for sending big blocks of data at high speeds, and it relies on a shared clock to keep everything in time. Asynchronous is for sending single characters at lower speeds, using those start and stop bits to frame each one. They're just two different tools for two very different jobs.
So, as we've seen, every single step of this data journey involves a choice, right? It's always a trade-off between things like speed, distance, and efficiency.
For parallel transmission, the choice is simple. You get absolutely incredible speed, but it's only going to work reliably over very short distances. It's a sprinter, not a marathon runner.
And with serial transmission, you give up that raw multi-lane speed, but what you get in return is toughness and reliability. It's the long-haul trucker of data communication. It makes sure the message gets there no matter how far it has to go.
And that really is the central challenge for all of modern technology. We want the insane speed of that parallel superhighway, but we also need the globe-spanning reliability of a serial connection. So the next time you hit send, just take a second to think about the incredible engineering that has to balance these trade-offs. Because finding new ways to get both speed and distance, that's what's going to continue to shape our entire connected world.